Welcome to the engineering class for November the 18th. I have looked at the homework that you turned in, and I will talk about it in just a minute. But before I do that, let's go over some announcements first. You know that this coming Saturday is the engineering day up at the U, which will actually be held online, but it's run by the University of Utah. And if you have not already signed up for it, please do. It is a very cool activity. They have some amazing laboratories up there. They do some really cool work and some great professors. And I will give you extra credit if you attend and if you write up a short description of what you saw and did. So that's this coming Saturday, don't forget. Also, be aware that the next time that this class meets will not be Tuesday. If we followed the normal schedule, so today is a Wednesday, right? So B day, and then Thursday's A day, and then Friday's a B day, even though we don't meet, which is kind of weird, but that's the way it works. So according to the normal schedule, Monday should be an A day, but for some reason, Cottonwood decided that they wanted to swap that. And so we have to swap it with them because we got so many students taking Cottonwood classes. So even though Friday is a B day, Monday is also going to be a B day. So we're going to have two B days in a row. And then Tuesday is going to be an A day, and then it's Thanksgiving. And so then the next Monday after that is going to be an A day also. So we're going to have two A days in a row. So I know it's goofy. Hey, don't blame me. It's just, well, that's what it is. So we can deal with it. So the next time that we'll meet will be on Monday, not Tuesday. So make sure you come here, not to your 8A class. And other than that, I think we're good. So let's start talking about last night's homework. So the homework assignment was to turn in the functional specification and also to do a couple of the calculations that would help you to prepare for the engineering specification. So many of you turned in the functional specification and also did the calculations. Some of you turned in the functional specification, but you forgot to do the calculations. And of course, there's a few that didn't turn in anything. Don't know what you're gonna do about you. Okay, so the functional specifications that you turned in for the most part were very good. A couple of you left out a few little details that I had to ding you a little bit for. Like for instance, some of you forgot to mention that after you did the countdown where the LED flashed 5 times and then 4 and then 3 and then 2 and then 1. Okay, at the end of that, the beeper is supposed to give a short little beep, just so that I, as a homeowner, can have a good, warm, fuzzy feeling, because that confirms to me that not only is the light working, but I also know that the buzzer is working, which is something I would like some confirmation of before I leave my home and go off to do whatever I'm going to do. So some of you forgot to mention the beep. Now, one of you said that I wanted the beep to do a countdown as well, but actually no. I just want the countdown to be with the LED. And then I just want one short little beep at the end of the countdown. Some of you forgot to mention that when the burglar comes, I want the light to come on and then stay on. So when the burglar goes away, I want the beeping to stop, but I want the light to stay on. Okay, so some of you forgot that. So, I mean, those weren't major deals. I didn't dock you a whole lot of points for that, but I did have to dock you a little bit. Those of you that didn't do the calculations, I docked you some more points because those were important. And we did talk last time about how to do them, so you should have known how to do them. So I see a question, somebody's asking me, when is class going to end today? Well, class gets out at 3:40. So if you're wondering when we're going to stop the live portion of the class, well, that depends on how many questions you have, but we might possibly go as long as 3:40. I mean, if you need to leave early, then hey, do what you have to do. Don't worry about it. Okay, so are you all good now on the functional specification? You all understand what it was that should have been in the functional specification? Because the assignment that's going to be due next week, so when we meet on Monday, the assignment that we do then is the completed burglar alarm. So between now and then, you need to go into Tinkercad and you need to create a burglar alarm that does everything that the functional specification requires it to do. That will be your homework. And this counts as a midterm exam. You know, the way it works in this class is at the end of each module, we have a project, something that you build or some problem that you solve that is the summary project for that particular thing. So on Monday, we will finish up the electrical engineering part of this class, and then we will move on to a different field of engineering. So the thing you do on Monday counts as a midterm. Make sure you do it. If you don't do it, that's like not taking a midterm exam, and it's kind of hard to pass a class if you don't take the midterm exam. Now, the calculations. Okay, so many of you did the calculations great. A fair number of you made some mistakes that I think were just silly mistakes where you kind of got two things kind of backwards. But some of you put in some numbers that were not even close. And so that had me worried that you didn't know what you were doing. So let's go over the calculations together. And let's make sure that everybody knows what you should have done and how you should have done it. And remember that what we're doing is being recorded. I will post it on Canvas later today. So if you don't fully understand everything we're doing, you can go back and you can watch the recording and you can pause it and you can get it. Okay, so you should now be seeing on your screen the Canvas page talking about the functional specification. Okay, so part one was to do the functional specification, and most of you did a really good job on that. But then you were supposed to also do another part here, and a fair number of you forgot this part. Okay, so what you were supposed to do was you were supposed to calculate what the input voltage to the Arduino would be if the burglar is not present. So that means that the photoresistor is seeing light. That's part A. And then part B was you were supposed to do it assuming that the burglar is present. So what that means is that the photoresistor is not seeing light, or at least not seeing as much light as it did before. Okay. And I told you to do it assuming that the fixed resistor had a value of 10 kilo ohms, which is what we had talked about the other day. And then the photoresistor had a value of 500 ohms when the light was shining on it. But the photoresistor had a value of 180 kilo ohms when it was in darkness. So you were supposed to do those calculations. And many of you did, but a large number of you either got it wrong by a little bit, or in some cases got it wrong by a lot. So what I'm going to do now is I'm going to go through this, and I might ask you guys for help. So if I ask you for help, be sure to unmute yourself and talk about how to do it. So let's open up a whiteboard. Now, before I do that, let me write down the numbers. So the fixed resistor is 10 kilo ohms. The photoresistor is 500 ohms when it's light, and 180 kilo ohms when it's dark. Okay. And you should all also know that since we're hooking it into the Arduino, so you see right here, can you see right, let me turn on annotation. So right here, maybe if I make that thicker, you can see a little better. You can see that we're plugging it into the 5-volt pin on the Arduino. So we are going to do this as if it was plugged into a 5-volt battery. Okay, so with that, now let's open up a whiteboard and let's see how we do this. Okay, so if I were to draw a schematic of our burglar alarm, we're going to have something that works as if it was a battery, even though it's coming from the Arduino. We can treat it as if it was a battery, and it's a 5-volt battery. Okay, and it comes and goes through a fixed resistor, and then it goes through a variable resistor. And the way we do variable resistors is we do a regular resistor symbol with that arrow going through it. And that way everybody who sees it knows that it's a variable resistor. Now, if it's a photoresistor, sometimes you'll see people use this little wavy line coming in there with an arrow. That's a symbol that's supposed to represent light. because there are variable resistors that aren't light based. You know, they have like a knob, and by the way, they're called a potentiometer. Okay, so there are variable resistors like that, but in this case, it depends on the amount of light. Okay, so anyway, let's put some numbers here. So in the homework that was due today, you were supposed to do the calculations assuming that this was a 10 kilo ohm resistor, which meant 10,000 ohms. Okay, now if the photoresistor was seeing light, then the resistance was supposed to be 500 ohms. If the photoresistor was seeing darkness, then the resistor was 180 kilo ohms, which is the same thing as 180,000 ohms. And so we have a line right here, and this is the line that goes to the Arduino. And so your job was to figure out what is the voltage that will be fed into the Arduino. And hopefully you understood when I said last time that the voltage that goes into the Arduino will be the same as the voltage difference across this resistor. So whatever is delta V across this resistor, that's what the Arduino will see, because this side of the resistor, this is connected up to that side of the battery. So this is basically ground, GND, which means ground. Okay. So if this side of the resistor is ground, then whatever is the voltage difference across the photoresistor, that is the voltage value that the Arduino will see. And you were supposed to calculate that. Okay, so tell you what I'm going to do. I'm going to do the calculation assuming that the photoresistor is seeing light. And I will do it for you once so that everybody has a reminder of how to do it. And then I'm going to pause and I'm going to let you do the calculation, assuming that it's dark. Okay, so first off, let's assume that it's light. So if it's light, we have two resistors. We have a 10,000 ohm resistor and we have a 500 ohm resistor. So what is our total? So if we were to take this battery here and we were to hook it up in a different circuit where that battery only had one resistor in it, where that one resistor is our total. So I want this battery and this battery to feel the same resistance. What would the number be? Okay, what would the total resistance be of these two resistors that are hooked up in series? Can somebody type into the chat box here? What would our total be? All right, okay, good. So I'm seeing 10,500, good. All right, so that is the total resistance. So now that I can use that to calculate what is the current that's flowing through the resistor or through the circuit. Okay, so if I look at this one right here, okay, I've just got one battery and one resistor. And so we know from Ohm's law that I equals V over R. And so the voltage is 5. The resistor is 10,500. Okay, so that's the current that would be flowing through this circuit. And that would be the same that's flowing through this circuit too, because the total resistance is the same in both cases. All right, so whatever is 10 divided, or whatever is 5 divided by 10,500. So when I get out my calculator, so 5 divided by 10500. So I get the total current. And now on my calculator, it's going to show it to me in scientific notation. So it's going to be 4.76 times 10 to the negative 4. And so that's going to be amps. So this is the total current that is flowing through the entire circuit. That's how much current is flowing through this fixed resistor. But because they're connected up in series, that's also how much current is flowing through the photoresistor. Okay, so now my next step is I want to know what is the voltage drop across the photoresistor. And so I can use Ohm's law again. I can take I equals V over R, and I can rearrange that by multiplying both sides by R. So that goes away. And so then that then leaves me with V equals R times I. So if I put in the total resistance, well, it's going to give me the total voltage, but I don't want the total voltage. I only want the voltage that's across the photoresistor. So what I need to do is I need to take the whatever is the resistance of the photoresistor, put it in for there, take whatever the current was, put it in for there, and then the voltage that comes out will be the voltage only across the photoresistor, not the total voltage. All right, so when I take that number that I just calculated and I multiply that by the resistance of the photoresistor, I get 0.24 volts. Okay, so that tells me that if the burglar is not present, then the Arduino is going to have 0.24 volts on the input pin. Okay. Now, I want you guys to do the same thing, but this time I want you to assume that the burglar is present. So the voltage is still going to be 5. That's not going to change. This resistor up here is still going to be 10 kilo ohms. That's not going to change. The thing that's going to change is this variable resistor down here. Okay. That is not going to be 500 ohms anymore. When it's in darkness, it is going to change to 180 kilo ohms. Okay, so I want you to do the exact same thing that I just did, except with the new number for our photoresistor. I want you to calculate step 1, what will the current be? And then once you know that, then you can go to step 2, where you calculate what the voltage across the photoresistor will be. And then I want you to type in your answer, but don't type it in a public message. Type it in a private chat message to me so that nobody else can see your answer. Okay, I will sit here quietly while you go. Oh, good. I see some of you are way ahead of me. All right, I see one answer. Let me see a couple more answers. Not seeing any more answers here. Okay, good. I just got another answer. And the second answer matches the first answer. That's encouraging. That doesn't guarantee that they're right, but it does improve the odds. All right, I just got another answer that, oh boy, the answers that I'm getting now are a little different. I mean, they're close, but they're a little different. So now I think maybe the problem is rounding. How about if everybody rounds to the nearest 1/10 of a volt? Okay, now I'm starting to see answers and they are agreeing. They're all pretty much the same answer. Okay, good. But I've still got a couple people who haven't typed in your answers yet. Okay, now I just got somebody who admitted that that they weren't sure how to do this. So thank you for your honesty there. All right, whoever just typed in your last answer, who, by the way, I will not name who you are, please give it to the nearest 1/10 of a volt. Don't round it to the nearest volt, round it to the nearest 1/10 of a volt. Okay, good. I just got another answer. Okay, so it looks like you guys are all getting the right answer here, except there's still a couple of you who have not yet typed anything in. So that has me worried. So let me see, who was the first person to type in their answer here? So that was Adam. Adam, you were the first person to type in your answer. So would you mind unmuting yourself and just walk us through what did you do to get your answer?
Okay, so it's the same thing as the last problem, just with different numbers. So
Okay.
the first thing you do is you take the original voltage, I guess you'd call it, and then divide it by the total resistance. So
Okay, so rather than calling original voltage, okay, well, okay. Original voltage. Okay, I see where you're coming from.
yeah.
Okay, so it sounds to me like what you're trying to do is you're trying to calculate the current, and you're using Ohm's law to do that. And you know that Ohm's law says it's V over R. And so V, you know, is 5 volts, which is what you called the original voltage, which, okay, I prefer to call it the total voltage. And R, we want R to be the total resistance. So what number did you use for the total resistance?
190,000 ohms.
Okay, because he just added these right. So he's got 10,000 plus 180,000. So the answer is 190,000. Okay, so when you did that, what number did you get?
Sorry, I don't have my thing open, but it was like 0.0000 something.
Okay, so let me do it on my calculator. So 5 divided by 190,000. Okay, so on my calculator, it comes out in scientific notation. So it comes out as 2.63 times 10 to the negative 5. So if your calculator is different, that would have come out as you'd have 4 zeros and then a 263. Okay, so this number and this number, they are the same. Just one written in scientific notation. Okay, Adam, what did you do next?
Then I multiplied it by just the second resistor because you're trying to find the difference between the two sides, the difference in voltage.
Okay, so I'm assuming the way you mean is you're using Ohm's law again. So
yeah,
you take Ohm's law and you've rearranged Ohm's law. So now you get V equals R times I. And the R that you're going to use is not the total resistance this time, it's just the resistance of just that one resistor, because that is what you want to know the voltage for. You want to know the voltage just across that one resistor. Okay, so we're going to take this number that we just got, that's the current, and we're going to multiply that by 180,000. Okay, and what number did you get there, Adam?
4.74 about.
Okay, good. And so if we round that off to the nearest tenth of a volt, that's going to round down, not up. So the number that we report will be 4.7 volts. Okay, very good. Okay, so now you can see if there is no burglar, then the Arduino will see 0.24. So if we round it off to the nearest tenth of a volt. So if there's no burglar, the Arduino is going to see 0.2 volts. But if there is, yes, a burglar, then the Arduino will see 4.7 volts. So that's a pretty big swing. That's a big difference between 0.2 volts and 4.7 volts. So I'm thinking this is going to work really well as a burglar alarm. Okay. So I hope everybody's good with that. Now, just to be absolutely sure that you're good with it, I have given you a new assignment because I could see that some of you were having trouble with it. So if we go into Canvas, all right, and go back to our modules. Okay, so if you scroll down to the bottom here, you'll see there are two assignments here that they're both going to be due by the time we meet next again. One of them here is due on November the 20th. That is this coming Friday. Now, some of you are going to say, hey, wait a minute, Mr. Hendricks, we don't meet on Friday. Yeah, that's correct, we don't. But Friday is not a day off. A lot of students think that Friday is a day off. It's not. It's a work day. It's just a day where you can work on your own. Okay, so this assignment that you see here that says different resistor values and resulting Arduino input voltages, that is due this coming Friday at midnight. And the idea is to give you some practice to make sure that you know how to calculate the voltages like we just did. But that's not the only assignment. We also have this assignment down here. This one is due on November the 23rd, and this is the final project. This is where you actually build the burglar alarm, and you submit the link so I can see that you've built it correctly. This is the one that is worth 100 points here. So this is the big one. This is the midterm exam. You can see here it says counts as a midterm exam. Okay, but that's not due till next Monday. All right, so let's talk about this one here, just so that there's no confusion about what I want. Let me click on preview so that you can see it the way that a student would see it rather than the way that we teachers would see it. Okay, so the first question says that I want you to use a 200 ohm resistor as the fixed resistor in your Arduino. So we're going to have the exact same burglar alarm schematic. It's just that the numbers are going to be different. So here's going to be our voltage supply. Here's our fixed resistor. Here's our variable resistor. Okay. So when we did this a few minutes ago, our fixed resistor was 10 kilo ohms. Well, I don't want you to do that anymore. This time I want the fixed resistor to be 220 ohms, not kilo ohms, just regular old boring normal ohms. Okay. Now the photoresistor, I want it to be the same as it was before. So the photoresistor still works so that if it is seeing light, then it's 500 ohms. And if it's dark, then it is 180 kilo ohms. And I use those numbers because that is what the photoresistor does that's in the Arduino. I'm sorry, that's in the Tinkercad software. And that's pretty typical. I mean, every photoresistor is a little different. It's hard to make photoresistors that are exactly the same. So if you buy a package of 50 photoresistors that look identical and you bought them from the same store at the same time and you think they're all identical, you're going to find that they're actually going to vary a fair amount. But they're going to be somewhere in this range. Okay, so let's stick with the same values for the photoresistor that we used last time, but our fixed resistor is going to be a different value. Okay, so what I want you to do for the quiz tonight is I want you to for question A, I want you to answer the question, what would the input voltage be to the Arduino if the photoresistor is fully illuminated? So you can do that calculation and type in the number to A and round it off to the nearest 1/10 of a volt. And then for part B, it's the same exact thing, same value for your fixed photoresistor, but this time I want to know what would the input voltage be if the photoresistor is in darkness. Okay, so just prove to me that you know how to do this. Okay, and then question number 3, we're going to change the fixed resistor yet again. So when we get down to question number 3, it's not going to be 220 ohms anymore. It's going to be 150, and it's not going to be 150 ohms. It's going to be 150 kilo ohms. So that's 150,000. Okay, and so now I'm going to want you to do it again. Okay, so with this new value for the fixed resistor, I want you to calculate what would the input voltage be to the Arduino if the resistor is fully illuminated. And then question number 4, I want you to find out what would the input voltage be to the Arduino if it's in darkness. So just prove to me that you know how to do the electrical engineering part of this. Because remember, that's the whole thing is what we're doing is we're learning how to be electrical engineers. And this is the kind of thing that electrical engineers do. Okay, are there any questions about that? Now you can see there is a 5th question down here. I'll talk about that in just a minute. But before I go into that, does anybody have any question about what we've just done? Not seeing any, not hearing any. Okay, so let's talk about the fifth question. So the fifth question here says, let's suppose that we've got some range. So if the burglar's not there, we get something like maybe about 1 volt. And the burglar is there, we get something like maybe 4.5 volts. And so we want to set our threshold somewhere in between. Now, if you want, you could set it exactly halfway between, but you don't have to, as long as it's somewhere in between. Okay. So let's suppose we've decided that we want to set our threshold at 3.7 volts. Okay, so what does that mean? That means that we want the Arduino to sound the alarm if the voltage increases above 3.7. Okay, so what number should we program into the Arduino? So do you guys remember that if you were to ask the Arduino, how much voltage are you seeing on your input pin? The Arduino doesn't tell you the number of volts. The Arduino gives it to you in a different format. So just in case you've forgotten, let's go into here and let's see. Before I do this, let me clear out some stuff here. Clear all that drawing up. Okay. Tinkercad was acting a little bit funny today. It's taking a long time to boot up. So what I did was I have my burglar alarm here. So before we answer the question for number 5, I just want to give you a quick demo of what I want you to do for your final exam. And let me just show it to you now here. So what I'm going to do is I'm going to start the simulation. And so you guys hopefully remember that my light should flash 5 times and then 4 times and then 3 times and 2 times and then 1 time. And then my beeper should beep once. Okay, so let's make sure that that works. So I'll zoom in a little bit just so you can see it more easily. Okay, so here goes. Let's see if the startup sequence works. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3. 1, 2, 1. But you notice a problem? It didn't just beep once, it beeped a whole bunch of times. And also, did you notice the light came on? So what happened was the Arduino behaved as if the burglar was there. Right when I turned on the alarm, the burglar was there. This is because of a weird thing in the way that Tinkercad works. Okay, when I start my simulation, Tinkercad assumes that the photoresistor is in darkness. So watch what happens. When I start my simulation, then I click on here, you see Tinkercad thinks that it's dark. So I have to slide it over here. Otherwise, it thinks the burglar is present. Now, did you hear that beep just now? Okay, that beep that you just heard, that was the startup sequence finishing. Okay, so let me do this again. So I'm going to stop it. So I'm going to start my simulation. I'm going to come down here really quick, move it over here. Do you see all the flashes up here? So it did 5 and then 4 and then 3 and then 2. And there. Okay, so there's the one beep. And so my Arduino alarm is now in lookout mode. Okay, now let's zoom in on here. So what I'm going to show you is really important, and I want to make sure everybody pays attention. I want to set my threshold so that the burglar alarm will go off if the slider is somewhere in the middle. I don't want to have to put the slider all the way over here in order for the alarm to go off. I don't want that to happen. Also, I don't want the alarm to go off if I just move the slider a little tiny bit. Like if I move the slider from here over to here, I do not want the alarm to go off. That would be what we call a false alarm. And so, because what might happen is that, let's suppose that I turn on my burglar alarm and I go away. And then what happens if a cloud comes by? Okay, so if a cloud comes by, the light value that's hitting my photoresistor, it's going to go down by a little bit. Okay. But it's not that the burglar is there, it's just that a cloud went by, and so the room got a little bit darker. Okay, so if I put my threshold too close to here, I'm going to get false alarms, and I don't want false alarms. I do not want my threshold to be here. I want my threshold to be somewhere in the middle. Now, it doesn't have to be exactly in the middle, but I want it to be somewhere in the middle. Okay, so I want it so that when I drag my thing over to about, okay, that alarm comes back and it goes off. Okay, so when I'm testing your burglar alarms, what I'm going to do is I'm going to drag this over a little bit to like maybe right there. And if the burglar alarm comes on, then I'm going to take off a couple points. I'm going to tell you, sorry, but your burglar alarm is too sensitive and it's susceptible to false alarms. Okay. If, on the other hand, it turns out that I have to drag the burglar alarm all the way over to here, if the burglar alarm doesn't come on until the slider gets over there, I'm going to take off some points for that because that's too far. The burglar might not completely block all of the light. In fact, the burglar is not going to block all of the light that comes into the photo sensor. You know, if this is the photo sensor here, okay, and here's the light, okay, and here's the burglar, okay, all right. The burglar doesn't block all of the light. Some of the light comes in, so here's a wall, say. Some of the light hits the wall and it comes in here, right? So if I have to drag the slider all the way over to here to where the burglar alarm, the sensor is completely, totally blocked, well, what's going to happen is kind of the opposite of a false alarm. What's going to happen is that the burglar might walk in front of the light here, but the alarm won't go off because some of the light is reflecting off the walls and coming in here. So if the burglar alarm goes on here, then I'm going to say that your burglar alarm is too sensitive. Okay, but also, you know, if it comes over here, if I have to put the slider all the way over to here before the burglar alarm comes on, then I'm going to say that your burglar alarm is not sensitive enough. Okay. So I want it so that it's somewhere in the middle. Now, it doesn't have to be exactly at the middle, but it needs to be somewhere in the middle. So it's not, I don't want it to be too sensitive. I don't want it to be not sensitive enough. I want to be somewhere in the middle. So your job is to find a good threshold value that you program into your Arduino so that when it sees the voltage rise above a certain threshold, that's when it turns on the alarm. And so your job is to find what is the best threshold to use. Okay, so now with that being said, now let's go back into here and let's find out how can we figure out if I put in a certain number of volts into the Arduino, what number does the Arduino report? Okay, so do you guys remember when we hooked up the Arduino, we had it hooked up like this. Now, okay, hey, it came on pretty fast that time. Okay, so what I have here is a voltage supply. And so what I can do is I can change the voltage here. I can make the voltage be anything I want. Now, if I put the voltage up here at like 20 volts, if this was a real Arduino, I would have just destroyed my Arduino. So guys, remember, with a real Arduino, you never want to put an input voltage higher than 5 volts in there, because otherwise you can destroy the Arduino. And I know from firsthand experience that that will happen because I've had lots of students destroy lots of Arduinos that way. So we don't want to go putting too much voltage in the Arduino. But with this software Arduino, it's kind of like a video game. You know, if you get killed in a video game, you just restart the game and you're good. So that's the beauty of these software Arduinos. Even though I'm putting too much voltage, it doesn't really kill anything. Okay, so let's say that I want to put in 1 volt. So if I click on here, and then I just come over here and type in 1 volt, okay? Okay, so right now the Arduino is seeing 1 volt coming into it. So if I were to ask the Arduino, what number are you reporting back from my analog pin A0? It's not going to be 1. It's going to be a different number because the Arduino reports it in what I like to call Arduino units. Do you guys remember what that number was? Any of you remember how many Arduino units is equal to 1 volt? Ah, very good. Okay, Adam remembers. Yes, and Giovanni remembers. All right, good. Yeah, and for the sake of those of you who don't remember, here is how you can tell. Okay, if I click on the code here, so I've got a little thing here. Let me start from scratch here. Let me go to just basic. So if you see, I've got these different types of code things. So if I look at the output here, one of my output options says print to serial monitor. So what it's going to do is it's going to put something on what we call the serial monitor. Now the default value is just the words hello world. So if I were to run my code right now and I open up my serial monitor, what I'm going to see is just hello world repeated again and again and again. That's not of any use to me. So instead of printing hello world to the serial monitor, I want it to read what is the voltage on whatever analog pin I'm on. And let's see which analog pin. Okay, so it looks like I've got it plugged into analog pin A0. Okay, so what I want the Arduino to do is to read the voltage that's on A0. Okay, so what I'm going to do is I'm going to click on input, and you see one of my things here. It says read analog pin right there. Now be careful. There's an analog pin and there's a digital pin. The pins down here at the bottom, those are the analog pins, not the digital pins. So if you put the digital pin in here, you're going to find it's not going to work. Okay, so we don't want that one. We want the analog pin. And you can see that we got a choice of a bunch of different analog pins. So if I were to plug it into analog pin A5, that would be this guy over here, then we're good. But that's not what I've got. I've got an analog pin A0, so I need to make sure it reads A0. Okay, and so now when I start my code here, so let's just remind ourselves, what have we got? Okay, so when I start my code, you can see that I'm putting 1 volt into A0. So if I want to know what the Arduino is seeing, I can open up my serial monitor, and there you go. So the Arduino is seeing 205 volts. Okay, so if I put this up higher, let's say I put it up at 3 volts, so the Arduino is going to receive that as 614. And so the number that you see down here, I like to refer to that as Arduino units. So 3 volts on the input pin corresponds to 614 Arduino units. So in the homework assignment, I want to know what would the input voltage be, or what would the Arduino report if the input voltage is 3.7? Okay, so I'm going to leave that up to you guys to decide. But I do need to warn you that there is a problem with the simulator software here. I cannot go to 3.7 volts. If I click on this, if I tell it 3.7, it won't give me 3.7, it gives me 3.8. So I can do 3.6, that's fine, or I can do 3.8, that's fine. But if I try to do 3.7 with the Tinkercad simulator, okay, it can't do that. Wait a minute, so why didn't it go to 3.7? 0.7. Okay, there we go. The Tinkercad simulator cannot do 3.7, it can only do 3.8. But the real Arduino, okay, the real honest Arduino, it can in fact do 3.7. So what I want you guys to do for the homework that's due on Friday is I want you to calculate what would the Arduino read if the input voltage is 3.7. Okay. Now, very last thing before I turn you loose to go to work. Okay. When you do the real assignment here, so let's go back here to the real assignment. Okay, so let's click on engineering technology. Click on modules. And then we come down to the bottom here. So this is the assignment that is due on Monday of next week. This is the one that counts as a burglar alarm. Okay. I do not want you to use the same value for your fixed resistor that I used for mine, or one that's even close to it. Okay. I want you to pick a resistor that is either less than 2 kilo ohms or more than 20 kilo ohms. Okay, so this is going to force you to make a decision about what threshold value to use. And so if everybody picks a different value for your fixed resistor, then everybody will pick a different threshold value. Okay, so your fixed resistor, I'm expecting that everybody will be different. Okay, and so the threshold value that works for one student will not be a good threshold value for another student if you have different values for fixed resistors. So this is the engineering challenge that you have to decide is you have to decide, okay, what value are you going to use for your fixed resistor? And then what should you program into your Arduino code as the threshold so that it sets off the buzzer if it goes above that threshold. Okay. And then in order to get credit, remember that you must not send me the link at the top of the browser. You know, up here, don't just copy the link from the URL from up there. You have to click on the share button and then the invite people, and then send me the link that you get from there, because otherwise I won't be able to open up your link. Okay. Are there any questions? Do you understand what you need to do for Friday? And do you understand what you need to do for Monday? So either type in yes or no into the chat box. So yes means you understand what you need to do. No means you have a question about it. I'm seeing a lot of yeses. Oh, okay, good. I see one person who was being honest and said no. Thank you for being honest. Okay, so tell you what I'm going to do. If you understand what you need to do, then you can go ahead and type bye into the chat box and you can leave. If you still have some questions, then stick around after everybody else leaves. And what I will do is I will turn off the recording so that you and I can chat without the conversation being recorded. So that way you don't need to be embarrassed. All right, so here goes the recording.